What I would like on the drawing is the single line ISO pipe run. Now, we're going to go over a little bit more of this tomorrow. But for now, I would like you to try and put it together. And then tomorrow, we will look at it in a little more detail and how we're going to handle corners, those types of things. For now, do a squared off corner. By that, when you switch from one plane to another, there should be a tight corner where the lines come in sort of perpendicular to each other. Yeah, right? You're on an isometric axis, so it's really 120 degrees, but it should be a sharp corner. All of your fittings will be butt welded. By butt, we put two things right next to each other. We call them butt them together. Remember how you display those? Yep, with solid fill dot. Okay. So go ahead and put those together as well as you can. Now, as you draw it, you need to have a north arrow on it. And to get it to work with the welding lab, they have invoked a convention. So we're going to follow their convention. If you read through the handout I gave you on isometric pipe drawing, the standard for a north arrow always goes up and to the right. The welding department wants it to go up and to the left. Okay? So when you're looking at your isometric drawing, your print, okay, like such, here's my print. Okay, we need to have a north arrow that will run on this axis, okay, up and to the left. So as you look at your isometric axes, they go like this, right? This one's going to be your north axis, right here. Conversely then, this one needs to be your elevation axis, that's your up and down. Your easting axis is this guy, right here. So please put it together in that fashion. So that's the north arrow and the single line ISO. Any questions on those two? Okay. Now you will be butting into a flange, and your pipe run will start with a flange. Remember how you do a flange? It's just a single line. Okay, so all of your pipe runs will start something like here, and then it will take off, okay, like such. And then it might turn this way, might turn back, might go up, go this way, whatever the case might be. Till you get to the end, and then you will again have a dual flange. Okay. One other thing I would like you to put on the print that you're doing, and let me quantify this. I want you to put this chart. Now there's a reason for that. It should have the flange number and your calculations for your pipe run in your XYZ axis or northing easting elevation axis. Now the reason for that is if there's something wrong on it, I can check it. I want to check your math. When you turn this in, turn it in with that chart on it. I will then redline it and assign a grade to it and give it back to you. We're going to print it again after that, and we're going to take the chart off of it. Because the welders, then, you all know they're going to build this. They don't want that. They want to be able to locate based on the northing easting elevation and calculate their own pipe runs. Okay, so we'll then print again. We'll take the chart off of it without any information on it other than northing easting elevation, and we'll add that to it, and I'll give you that information over there, and then we'll hand those over to them. And then in the rest of this semester, they will put those together, or some of them, depending on how many students they have. They might not do yours, they might. Okay? Any questions on, now on this chart, I just kind of threw together a quick one. This would be flange some point. So make yourself a little chart. Should be another line here. So put your axes across the top axis. Down here, you're going to say, this might be flange 3 to flange 18. Okay. Put your northing easting elevations that you gathered up there, and then do the math in between them. This is fractional math. If you can't remember how to do that, you can get with me, but I ran a quick example for you. Hey, this one's pretty straightforward, where I'm north 1642 and I'm going to north of 1636. Am I moving? Well, my difference is 6 feet 1 inch. Is this run going north or south?
North.
If this is my start point, this is my end point, am I going north or south?
You're going south.
It will always be opposite of what you got here. This is a positive number, right? And northings get positive as you go to the north. So if you calculate the difference between them, it comes up positive, you're actually going south. Okay, because where your start point has a higher north than when you're subtracting. I kind of showed that again with elevation. Okay, so here I'm starting at 110 feet 4 inches. I'm going to end at 111 feet. I get a negative number in that calculation. Well, this thing's actually going up. Okay, but my difference that I'm going is going to come out opposite of the direction I go. Now, that's not really important. It's just an indicator of it. What you really need is only the 11 feet. You know the line's going down. But you're going to have both flanges on there with the lower one here and then end up with another one here or here, whatever the case might be. Now for fractional math, I put one together here that's a little harder to calculate. So this is 842, 6 1/4, 851, 7 7/8. Okay. Now 6 1/4 is less than 7 7/8. Okay. So just as a review of fractional math, how did I do that? I went and took my 6 1/4. I can't subtract that, right? So I added 12 inches, or I took 1 foot off of here. That's 12 inches. And I changed that to a 1. I took that 12 inches and added it to the 6. That gives me 18 1/4 inches minus the 7 7/8, which is here. Okay, does that make sense? Any questions on what I did there? Once you do that, with fractions, you have to have a common denominator. This one's an 8, this one's a 4. The denominator is the number in the bottom. Okay. So therefore, I changed this to an 8. I times it by 2. I get 2 8s. That's still a quarter, right? If it's reduced. Any questions on what I did there? Feel free to ask, it's okay. Might have been a while since you've done this. Okay, now 2 8s I can subtract from 7 8s, but 7 is still larger than the 2. Okay, so what I then did is took 1 inch off of here. 1 inch is equal to 8 over 8 as a fraction, correct? So I took 8 over 8 and added it to that, and I got 10 eighths. Now notice the inches dropped by 1 because I had to take an inch away to get that 8 over 8 to here. So that gives me 17 and 10 eighths. Now I can subtract 7 and 7 eighths. So I'm going to subtract these two. I got 10 minus 7 is 3. So I'm at 3 eighths. 17 minus 7 is 10. So that gives me my inches. It's 10 and 3 eighths. Now, this is now 841 right here. Okay. So I can then subtract that. That is going to be a 10. So it's 10. In this case, I'm going 10 foot, 10 and 3 eighths inches. Just kind of a review of fractional math. If you have any questions on this, get with me or some other person in here that knows how to do it. Work in fractional math very long, you're going to get to where you say, why aren't we base 10? Why aren't we doing metric? Fractions come to you very quickly once you get used to using them. By the way, when we go civil engineering, that field, the last class we'll do this year, we're going to switch this to a base 10 system instead of a base 12 system that it is currently. Can I erase this?
No, hold on. I'm recording too, so.
Did I do it right?
Oh, I was listening to those.
Does anybody have a construction calculator? You do?
Yeah.
Okay. bring one in so you can see it. There are calculators, and some of your handheld calculators probably work in fractions also, don't they?
Yeah, you have to
Switch
switch the settings in order to do that, though.
Yeah, many of them do.
Actual construction calculator is a lot easier to use.
Yeah, I'll bring mine in so you can see how to use a, like a Stairmaster or whatever these ones are. Are we all good? No? Are you good? All right, we'll talk more about that ISO tomorrow. It's not going to be due until Friday. Okay. But you can put together as much as you can now, and then I'll handle the corners and the finished print tomorrow. All right, back to our house. Juan, would you mind hitting the light for us, please? As I mentioned earlier, when you're doing these, you really want to concentrate on one plane at a time, and then trace those heights around till you finish up, and take it one part at a time also. By that, I would draw the whole house before I ever went to the roof, and then I'd treat the roof as two drawings, and then mesh the two together. And in essence, that's the way I'm going to work with this. So, in essence, here's kind of what we covered this morning, where I got the body of the house, I got my 3 windows, 2 doors drawn in. Were there any questions on what we did this morning on this? Okay. Now, let's talk about the roof. I'm going to get a little further away so I can deal with both of these drawings at the same time. And if you would, make sure yours is pulled up. I'm going to use this little mock here for a second as we talk about it. Now, remember on the roof plan, up here, you're looking at it like you're in a hot air balloon looking down on it, and you see the eaves, you see the ridge. You also have an elevation over here where you're looking at it in some sense where you see this main roof as an edge like this one. So you see the front edge and then the ridge is the limiting element at the top. That's what you see here. When you're looking at this one right here, you're looking at the profile of it, so this right here. These are called gable roofs. They're basically 2 inclined planes that meet at a peak. Okay, that's what we call a gable roof. The ends of these are straight. Okay, so they come straight up till they meet the roof. Now, when we talk about a roof, there's 3 components to the eave, or the eave is the overhang that comes from the wall to the edge of the roof. That's composed of a soffit, which would be the underneath part, and the fascia, which is the straight part on the outside that you see from the edge of the road. The thing we're going to do here is most people will box these in or make them straight on the bottom to cover this little gap. We're not going to worry about that, but I want you to think of these as just 2 linear planes tilted on edge. They have thickness. There will be a top surface to the roof, and there will be a bottom surface to the roof. This is going to be defined by your fascia. So when you're looking at this view right here, you're seeing the top right here. When you're looking here, you got that thick line, the dual lines right there. You're going to see on edge the top, and then the other one's considered the bottom. This portion right here goes straight up to from the wall into the bottom of the roof. Okay, so it's going to come straight up until it meets with the roof, exactly like this thing. Okay, that's the way I want you to draw this. We're not going to box in these things, okay, just to make it easier. So the point I want to make is, make sure when you're drawing on the top of this roof, you are going to points that are on the top. When you are looking at the bottom of the roof, make sure you go to points that are defined on the bottom. And on this view, all of the roof points you see with this yellow line, are they on the top or the bottom of this roof?
Top.
Are they up here or are they underneath it? The yellow line only.
Top.
They're all on the top. I'm going to need some points underneath the roof. That will be, and you've got several of them, but where the green line, it comes underneath. Remember, that's the wall. That's where it comes up and meets the bottom of the roof. So these are the two you really got to pay attention to, this one and this one, right here. Okay, because those two are vertical ends as they come up. Now, also as you look at this, keep in mind, this is an inclined plane here. Okay? So these things are sloping when you look at this. Okay? So that one is sloping up, that one's sloping up, that one's sloping up, and that one's sloping up. Okay? Do we all understand that? Okay, because you really got to pay attention to these things because the orthographic view is going to draw your isometric view. And you need to understand what you've got for information here. Any questions on what we've talked about so far? Okay. Now, with that said, let's go ahead and put the roof together. Now, as we deal with the roof, first thing you always ask yourself, where are my heights coming from? Where do you have true height of the roof? Now, you need 3 heights. Well, actually 4. And they're defined by fascia. You'll notice over here, I've got 2 lines that are the fascia of the bottom of this roof. I've got 2 lines running up this way, which are the 2 here. And then I've got a peak also. So I need 2 points at the top that define the very top edge of the roof and the bottom of the roof. On the edge, I need 2 points to define the height of that fascia. Now, as you look at this view, where are you true size in relationship to the roof and the roof only? That's all I care about. Because we need true size. We're switching heights.
That point is.
Okay, so I have true size. There's one. There's one. Let's deal with just the big roof. Folks, don't use true size on an inclined plane. They use it on a normal plane. Okay. Which one of these is on a normal plane? This one is. If I bring that and project it over, that one sits approximately right here, right? If you measured from this edge over, you could come over and measure on this edge over, and that's going to be where that falls. Is this a normal plane right here?
Yes.
It is. Okay, that's a good point to use. Don't use this one here, because that one is sitting up in here somewhere. It actually comes through, but it's hitting somewhere up in there on that inclined plane. Okay, so that one, it doesn't really do, you can use it if you're really good at this stuff, but it makes it harder than it has to be. So I'm going to use this point. Now, when I come to this one, okay, I don't really want to zoom in because I'm going to show over here. Yeah, feel free to come on up here. I cross again in 2 places. I cross right there, and I cross right there. Which one of those do you want to use? Amy, you're saying this one over here?
Yeah.
You're kind of pointing that way. You're going to use the one to the right or the one to the left?
Well, I would say right.
Okay. The right one is going to fall somewhere about right there.
Yeah.
Are you on an inclined plane?
Yes.
Yes. Don't use an inclined plane.
So the one to the left, that's gonna
Go.
go in, but we can't see that one.
You're right. I can't see it. It's right here. It actually falls back inside of this, but it's right on that corner.
Yeah, we'll see it as a point.
But it's back into it a little bit, right?
So we would use,
we see that plane as a line here, but we can get heights off of it. So that's the one you want to use.
not the
you-
inclined plane, because it's too
Yeah.
hard.
Use where you cross right here.
Okay.
Now that's going to give me the base. Here, here, it's going to give me this, and it's going to give me this. I can get all those heights from those 2 points. And in fact, really, I only need one of them, this one. I'm going to use just this one. The other part we have is your ridges. Where do your ridges cross the picture plane? They don't. Make sure when you extend them to the picture plane, you follow the angle the ridge goes at. Okay, now you cannot extend an X-ref. This thing's treated like a block. So what you'll end up having to do, when I go to draw this peak, I'm going to draw a line right over the top. That'll give me a line I can extend. Then I'm going to extend that to the picture plane on that same angle. Once I hit here, I can then use this guy to determine that height. Okay, just like we did with the 2-point. When I do this one, I'm going to do the same thing. I'm going to draw a line, then I'm going to extend it to the picture plane. And I'll determine that height. Once I've got the heights, then I just locate where the roof actually sits, which in this case is from here to here, and from here to here. And that will define the top. I'm going to carry the bottom with me because I will see up underneath this roof. Remember, this is only 6 feet off the ground where my eye is. And so I'm going to see up underneath that roof, right? Because the roof's higher than 6 feet. So I'm going to have to be able to deal with the underside of the roof also. And now I think this will kind of pop out when we do this, but I wanted to explain the process. Okay? So you're dealing with your heights. Any questions so far? So let me go ahead and draw this in. Okay. Need my glasses. All right, so here's true height right here. So I'm going to bring this and grab that true height, bring it straight down. Now, I need that height of that fascia. I'm going to get it from over here. So the fascia goes right here is the top of it. Let me just draw this through. Okay. So there's the top of it. Now I'm just going to copy this line from there to there. Okay, that gives me the height. Once I've got that, I'm going to come back over here and let me trim out the section I need. So I need that and that. And I'll delete everything else. Now I'm going to go ahead and throw this on my text layer. Because this is true height of my fascia, correct? Okay. Now when I located that true height, it was right here. Is that a vanish right or a vanish left plane?
Right.
Vanish right.
Oh, yeah.
Okay, so I need to take care of that. Then I'm going to use this height, and just like I drew the walls, I'm just going to trace this around. So I'm going to take the top of this guy from here, and should have put my lines just a little bit closer. Line from there to there to there. Okay. Now there it is. I know it comes out to this side too, right? There's some over here. So again, I'm just going to take a line out here and extend to it. Okay, so let's just extend that character to it. So there's top and bottom. Now I need to locate the two ends. The two ends are, one's right here, the other's right here. We use the station point for that. So I'm going to come from the station point to here. This line is in front of the picture plane, so what do I do when I got that?
Extend it back.
Okay, I just extend through it, and then bring that point down. Let me go ahead and get the other side. Which is right here. And I'll bring this point down. Let's see. Okay, now we can trim that up. So I'm going to do a trim. So it goes from there to there, that one, that one. These are deleted. That's deleted. Come out to this side. And we're trimming this edge up. Okay. There is the fascia along the front of the house. Okay. Now, when I get to here, remember, this point is now common to the fascia coming this way, right? So I've got the heights determined. I'm just switching to a vanish left plane. So I can use this to find this. So again, that vanishes left. So I'm going to come from that top point to my vanish left, oops, and then back. Okay. Now it's not really there, it's over here, right? But that just determines the angle all this is running on. So again, I'm just going to come out here. I know it'll go past this corner, so I'm just going to give myself a line there to extend to. throw that out, and then throw these two to it. So it goes there and there. Just to clean it up, I'm going to now do a trim back on that line and get rid of these over here because they're kind of confusing. Okay. So I've got this point located. I need to locate where it ends here.
I use that point.
Yep, use the station point for that. So we'll go from the station point to that front corner, which is right here. Again, I'm in front of the picture plane, so I'll extend through it and then grab that point and bring it down. That then gives me this end. So let me trim this. Now let me clean up a second. That's gone. What am I at here? Both of those are back. So there it is. Now I'm leaving, there's my true size. I use that to define the top and bottom of this plane. I located end, located end. I use this one, vanishing left, to locate top and bottom, and then I use station point to locate that end. Now, if I go to find the fascia over here, remember this is a vertical wall that comes up underneath the roof. Is the fascia on this side of the house that runs back behind it, is it the same height as this?
It should be.
Yeah, it is. It doesn't go here, it actually comes up and down, but I know it's the same height, so I can use it to find this height, even though it's not there. Is this a vanish right or a vanish left plane?
Right.
It's a vanish right. So, to find that other edge, I'm going to come here, go from this point to right and back. Oops, that snapped.